This video should help you with your Lab 5 calculation for the latent heat of fusion of water. So what we have here is a piece of ice at -5 degrees Celsius being added to a warm cup of water. The cup is made out of styrofoam, so you do have to worry about its specific heat capacity. After the ice has warmed to zero, melted, and mixed with the water, you have a final mixture that is at 3.5 degrees Celsius. And the water in the cup initially start at 15.5 degrees Celsius. So it's a case of heat lost by the cup and the water must equal the heat gained by the ice. I like to use all positive numbers. As long as you balance heat lost to heat gained, you should be okay. So the thing you should be aware of is that the ice, if you just look at the ice, it starts at -5. It has to absorb heat to get to zero before it can melt. So this would be 0. Once it's at 0, it then absorbs more heat as it melts, doesn't change temperature, and then it will warm up to the 3.5 degrees Celsius. So these are actually 3 different processes. This is the ice warming, and that would be Q, let's call it Q1, would be MC ice, delta T. This is the ice melting. That's the phase change. We'll call that Q2. That would be MLF. And this is the LF. This is what you're trying to find. This is the unknown for this experiment. And then this is simply the 0-degree water warming. And that would be Q3, which would be MC delta T. Now the thing here, this is C ice for specific heat capacity of ice. Down up here it's C water. Okay, so when you do heat lost equals heat gained, well, let's start with gained on the left. Heat gained equals heat lost. So gained by the ice would be the MC ice delta T plus the MLF. And this is all the same mass of ice. This would be the mass of ice, the mass of ice, and the mass of ice. Those are all the same masses. Whatever the mass of ice is, and you're given that. And then MC water delta T. And this would equal the heat lost by the hot water. So that's just MC water delta T. This would be for the water, mass of water, plus the MC delta T for the cup. So this would be S for styrofoam cup. Now, because I like everything positive, it means all delta T's are positive. So this is the tricky thing. So this delta T, hot minus cold, just always go hot minus cold. And you're going to get a positive number. So hot minus cold here would be 0 minus -5. So that delta T is +5. There's no delta T for the MLF. This would be hot minus cold. So it starts at 0 and it goes up to 3.5. So this delta T would be 3.5 minus 0, positive 3.5. The water, it starts at 15.5 and goes down to 3.5, but we want hot minus cold. So it'll be 15.5 minus 3.5. So that's +12. The styrofoam always does exactly what the water in the styrofoam cup does. So this would also be 12 degrees Celsius. Okay, so those are all your delta T's. They're all positive. Make sure you put them in the equation positive. C for ice, you have to use the C for ice, which you're told is 2108 joules per kilogram degree Celsius. And the C for water, you're told to use 4186. This one is the water from the ice. This one over here is the hot water that's already in the cup, but that's okay. It's still water. And you're going to use 4186. Here, this is the styrofoam cup. And so this one is for styrofoam, which is 897. Okay, and then your masses. Remember, this is the mass of the cup. Sorry, mass of the hot water. I don't have the numbers right here, but that's the hot water that's in the cup. That's the mass of that. This is the mass of the cup. This is the mass of the ice. And that stays the same. My ice, ice, ice. So I'd recommend you put all your numbers in everywhere, and then the thing that you're trying to find is this. Okay, so that's your unknown. And you have to carry all the uncertainties for all those calculations. So what you should do is calculate the number, like take this first term, get the number, whatever that value is, plus its uncertainty. And so use the uncertainty for the temperatures to get the uncertainty and the uncertainty for the mass. And then calculate this term with uncertainty, calculate that term with uncertainty, and that term with uncertainty. So for example, it's going to be something like, I mean, they have to balance. It might be 200 joules for that first term, and then plus MLF, and then this one might be, I don't know, say it's 100 joules. And that's going to equal, say, I don't know, say 250 plus 350. And these are completely made up numbers, but you get the idea. So if over here we have 300 joules plus MLF is equal to 600 joules, well, then you know that the MLF's got to be 300 joules. And all these numbers, they have to be positive, 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 and positive. Whatever's left is the MLF. So I would work through just that way, do your MLF, and then your final LF, of course, would be the 600 minus the 300 divided by the mass of ice. Okay, so I hope that helps with your lab calculation.